Welcome. This video is presented by Ajit Kumar Nair, a rehabilitation professional, counseling psychologist, and clinical hypnotherapist at Nair's Epigenetic Wellness in Indore. Close your eyes and touch your nose. You didn't have to look at your hand to know exactly where it was. That automatic awareness is proprioception, our hidden sixth sense. It is the continuous, subconscious tracking of where our physical body parts are in three-dimensional space. Under the surface, specialized receptors called muscle spindles are constantly detecting stretch and tension. They fire off rapid electrical pulses that travel up nerve pathways via neurotransmitters, sending real-time positional updates to a central hub in your brain to coordinate your movements. On the autism spectrum, this specific feedback loop, the critical connection between muscle and brain, operates differently. This slide on sensory processing research shows that over 90% of autistic individuals experience these sensory differences. Proprioceptive dysfunction in autism represents a specific neurological difference in how the brain interprets physical reality. When the brain struggles to map the body's coordinates, simple actions require intense effort. We call this dyspraxia. Motor planning, the ability to sequence movements for a task, like running across a yard or holding a pencil, becomes a daily exhaustion. Without an accurate internal compass, sensing spatial relationships gets complicated. A child might struggle to maintain balance while walking, or find it difficult to sit upright in a chair because their postural control lacks steady feedback. Looking at proprioceptive seeking behaviors, when the internal signal is weak, the brain craves louder input, seeking heavy pressure or repetitive fidgeting. These body positioning patterns and self-regulation mechanisms show that using weighted items provides much-needed sensory grounding. What often appears as clumsiness is actually a dysregulated nervous system working to map its place in the world. Modern neuroimaging gives us structural evidence that these behavioral differences originate in the brain's architecture. This table breaks down the underlying neuroscience. fMRI studies reveal autistic individuals display distinctly altered processing patterns in the sensory motor cortex during body position tasks. The structural analysis row indicates reduced white matter connectivity. These physical variations in brain's communication highways impair sensory signal integration. Placing this vulnerable sensory network in a chaotic environment, like a crowded physical education class, overwhelms the system and further reduces coordination. Trying to manually process every movement carries a heavy cognitive load. For those dealing with anxiety or ADHD, the effort required to navigate a hallway drains the executive function needed to plan and focus. Navigating a busy school or workplace consumes significant mental bandwidth because the brain is constantly preoccupied with basic postural regulation. Unaddressed proprioceptive issues lead to long-term social challenges. Repeated difficulty with active play isolates children from their peers, which can lower confidence during critical developmental years. In the classroom, poor fine motor control makes writing taxing. This reduces academic stamina and turns timed examinations into a measure of physical endurance rather than actual knowledge. Standardized clinical evaluation helps identify these deficits early. Occupational therapy evaluations use structured observation protocols to measure motor planning and postural control in real-world environments. Next, differential diagnosis considerations show clinicians must distinguish these challenges from other patterns, like vestibular dysfunction or cerebral palsy. A precise multidisciplinary diagnosis provides the necessary foundation for an effective, targeted intervention plan. Occupational therapy serves as the primary treatment through methods like sensory integration therapy. Resistance exercises, heavy physical work, and the use of weighted vests provide intense, deliberate sensory input. This added resistance helps the brain organize scattered signals into a clear, usable wave of information. Within the classroom, individualized education programs can implement vital accommodations, including specialized seating and scheduled movement breaks to help the student focus. Parent coaching ensures that these sensory strategies and predictable routines are integrated into daily life at home. The most effective proprioceptive support involves around-the-clock adaptation of the individual's entire environment. During adolescence, rapid physical growth spurts alter the body's center of gravity, forcing individuals to constantly recalibrate their body awareness and movement strategies. As an individual matures, the focus shifts toward independence and life skills. This section highlights the importance of self-care development and functional adaptations to support vocational competence. Emerging care options include virtual reality therapies that provide real-time movement feedback and precision medicine models that account for an individual's unique genetic profile. Reducing the constant noise of sensory dysregulation allows the brain to focus its energy on social interaction and vocational skills. When we provide early identification and customized support, we give individuals the tools they need to navigate their world with autonomy.